Hello, I'll be evaluating a PA4000 to a real-time oscilloscope. My device under test will be a brushless three-phase motor. My measurement equipment is connected to the motor drive in a three-phase, three-wire configuration. I will show the PA4000 measurements through the Power Analysis software PowerView. The PA4000 is connected to my PC through USB, but Ethernet and GPIB are also options. After I've added the power analyzer to the software, I can begin configuring the measurements. First, I'll rename my channel 1 and channel 2 and change the measurement configuration to three-phase, three-wire as mentioned earlier. I also have the input side of the motor drive being measured and will rename channel 3. Since the motor drive is pulse width modulated, I need to configure the mode to PWM. An abundant number of measurements are available, but I'll just select a few for this presentation. Once you select play, the configuration will be uploaded to the power analyzer and measurements will be updated on the display. We can view the waveform by selecting the waveform button and select whichever channel you want to view. Harmonics can also be viewed in a bar graph. Now let's compare what we see to a real-time scope. You might think something is wrong at first, but remember that our motor drive is pulse width modulated. That large amplitude and noise you see is really there. To make them look the same, I'll apply a smoothing filter to the scope. The math channels have a filter, so I can now turn off the analog channels. They are looking more similar now, but they are still not the same. This is because the waveform in the power analyzer is a summation of all your measured harmonics. By increasing the measured harmonics up to 100 on both voltage and current, they should now look the same. We can also check the motor drive input. Let's go ahead and compare the power analysis. The scope has an accuracy of 3% and the PA4000 has an accuracy of less than 1% off. And looking at the voltage RMS values, the scope deviates by less than 2% and the current RMS has less than 1% deviation. That's it, people. For more information, send us your questions. Bye.